Welcome to this comprehensive tutorial for beginner Unity developers, where we will explore the power of scriptable objects for managing modular data. This guide will walk you through the fundamental concepts, creation process, and practical applications of scriptable objects, helping you build more organized and efficient Unity projects. Scriptable objects are specialized data containers in Unity, designed to store large amounts of shared data independently of specific class instances. Think of them as blueprints for data, allowing you to define a structure for information that can be easily reused and managed across your game. Unlike monobehaviors, which are components attached to game objects in your scene, scriptable objects are not attached to game objects. Instead, they exist as standalone assets within your project, promoting a cleaner and more decoupled architectural design for your game's data. They are incredibly useful for efficient data management, significantly reducing memory usage by preventing data duplication and fostering highly modular code structures. This separation of data from logic leads to more maintainable and scalable game development. Scriptable objects can store diverse data types, from simple integers and strings to complex arrays and lists, making them exceptionally versatile for various game elements. Whether you need to store player statistics, item properties, or configuration settings, scriptable objects can handle it. A key benefit is modularity, which involves separating data from logic. This crucial distinction allows you to modify data values without altering the underlying code that uses it, and conversely, update code without needing to touch the data. This flexibility is a cornerstone of good software design. They offer excellent reusability, as a single scriptable object asset can be referenced across multiple objects and scenes throughout your project. This prevents data duplication, ensuring consistency and making updates much simpler and less error-prone. Their seamless integration into the Unity editor simplifies creation, editing, and management. This empowers designers and non-programmers to directly modify game assets and data without needing to write or understand any code, streamlining the development workflow. Memory efficiency is another significant advantage. By centralizing data in scriptable objects, you avoid creating redundant copies of the same information. This shared data approach significantly boosts performance, especially in large-scale projects with many instances of similar data. Furthermore, data stored in scriptable objects can persist between game sessions, making them ideal for saving game settings, player profiles, or other crucial data that needs to be loaded and maintained across different playtimes. This ensures a consistent player experience. Now, let's dive into creating your first scriptable object. The initial step is to create a new C# script within your Unity project. This script will define the structure of the data your scriptable object will hold. Open the newly created script in Visual Studio. You'll need to change its inheritance from monobehavior to scriptable object. This fundamental change transforms the script from a component that attaches to game objects into a standalone data asset. To easily create instances of your scriptable object directly from the Unity editors, create Menu. Add the Create Asset Menu attribute above the class definition. This attribute takes parameters like file name and menu name to customize its appearance in the editor. Next, define the public variables you wish to store within this scriptable object. These variables will represent the data structure for your asset, such as a weapon's name, damage, or attack speed. These will be editable directly in the Unity inspector. For private variables that you want to expose and edit in the inspector without making them public, remember to use the serialized field attribute. This allows for encapsulation while still providing editor access for designers. Here's a complete code example for our weapon data scriptable object. It defines essential properties like its name, damage value, attack speed, and even includes a reference to a GameObject prefab, demonstrating how versatile these data containers can be. With the script now fully defined and saved, return to the Unity editor. You can now easily create instances of your custom scriptable object directly from the project window, ready to be populated with specific data. Select the newly created Stored Data asset in your project window. In the inspector, you can now populate its fields with specific values, such as entering broadsword for the weapon name and 15 for its damage, customizing this particular weapon instance. You can create multiple instances, such as axe data and bow data, each with unique properties like different damage values or attack speeds. all based on the same weapon data script. This showcases the power of reusability and modularity. Now, let's see how to effectively use these scriptable object instances within another component or script in Unity. This is where the data you've defined becomes active and influences your game's logic. Open the weapon script in Visual Studio. Inside, create a public variable of your scriptable object type, in this case, public weapon data. This variable will serve as the link to your data asset. Back in the Unity editor, create an empty game object in your scene and attach the weapon script to it. This game object will now be able to access and utilize the data stored in your scriptable object. With the player weapon game object selected in the hierarchy, drag one of your scriptable object instances, for example, sword data, from the project window to the weapon data field in the inspector. This assigns the specific data to your weapon component. Finally, within your mono behavior script, you can now easily access the data stored in the scriptable object through this public variable. This allows your game logic to dynamically react to the data defined in your assets. Here's the complete code for our weapon mono behavior. It demonstrates how to access the scriptable object's data, specifically logging the weapon name and damage to the console when the game starts, confirming the data link. When you run the game, the console will display the weapon's name and damage, confirming successful data retrieval from the scriptable object. This simple output validates that your scriptable object is correctly integrated and providing data to your game. Now for some beginner-friendly tips to help you master scriptable objects and integrate them effectively into your Unity development workflow. These insights will help you avoid common pitfalls and leverage their full potential. Always use scriptable objects for data that needs to be shared across multiple objects or scenes. This approach helps maintain consistency, reduces memory overhead, and ensures that changes to data are reflected everywhere it's used. Leverage the Create Asset menu attribute. It significantly streamlines the process of creating new scriptable object assets directly in the Unity editor. This small addition saves time and makes your custom data types easily accessible. Remember to use the Serialize field attribute to expose private variables in the inspector. This allows game designers and artists to tweak values and balance game mechanics without needing to delve into the code itself, fostering better collaboration. Consider scriptable objects for game settings, player profiles, and any other data that requires persistence between game sessions. Their ability to store data as assets makes them perfect for configurations that need to be loaded and saved. Experiment with different ways to integrate scriptable objects into your projects. There's no single right way, and finding what works best for your specific needs and project structure is key to unlocking their full potential. Crucially, remember that scriptable objects cannot be attached directly to game objects. They exist solely as assets within your project. They are data containers, not components that provide behavior to game objects. Scriptable objects are incredibly versatile and have numerous common use cases in game development, extending far beyond simple item data. Understanding these applications will broaden your perspective on their utility. They are perfect for game configuration, storing settings like volume levels, difficulty, and screen resolution. By centralizing these settings, you ensure consistency and make it easy for players to customize their experience. You can define all your in-game items, such as weapons, armor, and potions, using scriptable objects for easy management. This allows for rapid prototyping and balancing of item properties without touching code. Character stats like health, mana, and attack power can be efficiently stored and managed using scriptable objects. This makes it simple to create different character archetypes or enemy variations by simply creating new data assets. Level data, including tile maps, enemy spawn points, and objective locations, can also be structured with scriptable objects. This provides a clear and organized way to define the layout and elements of each game level. For UI elements, scriptable objects can store data like button labels, text sizes, and color schemes, ensuring consistent UI design across your entire game. This promotes a cohesive visual experience and simplifies UI updates. Dialogue systems benefit greatly from scriptable objects, allowing you to manage complex dialogue trees and character interactions. Each line of dialogue, choice, or character response can be an entry in a scriptable object, making narrative design more manageable. AI behavior patterns and decision-making processes can be defined and configured using scriptable objects, making AI more modular and easier to iterate on. You can create different AI personalities by simply swapping out their behavior data assets. Finally, scriptable objects are excellent for creating global game events that can be accessed and triggered from any object in your game. This allows for a decoupled event system where various parts of your game can communicate without direct references. While typically created in the editor, scriptable objects can also be instantiated at runtime using the create instance method. This opens up possibilities for dynamic content generation and advanced data handling during gameplay. This is particularly useful for generating dynamic data, such as procedurally generated item properties, or loading information from external sources like JSON files during gameplay, allowing for highly flexible game content. To save a runtime-created scriptable object as an asset within your project, you can use the assetDatabase.createAsset method. This allows you to persist dynamically generated data for future use in the editor. It's important to note that asset database methods are editor-only and cannot be used in a standalone player build. These functions are specifically designed for development time asset management within the Unity editor. When working with scriptable objects, there are several important considerations to keep in mind to ensure proper data management and avoid unexpected behavior. Understanding these nuances is crucial for robust development. In the Unity editor, changes to scriptable objects are automatically saved. However, changes made via script in edit mode might require explicitly calling editor utility setDirty to ensure Unity recognizes and saves those modifications to the asset. In a standalone player, you can only read data from scriptable object assets. You cannot save changes to them at runtime, as they are compiled into your build as immutable data. Any runtime modifications will not persist. Calling destroy on a scriptable object releases its native resources, but the object itself remains in memory until garbage collected. This is an important distinction for memory management, as it's not immediately removed. For scriptable objects that function as singletons in edit mode, meaning there's only one instance across your project, scriptable singleton T0 can be used as a convenient base class to manage this unique instance. For runtime singleton scriptable objects, you must implement your own singleton pattern and manually manage asset creation and loading. This requires more custom code to ensure a single, accessible instance throughout your game's execution. By understanding these concepts and techniques, you can effectively use scriptable objects to create more modular, efficient, and maintainable games. They are a powerful tool for any Unity developer looking to improve their project's architecture. Thank you for watching this tutorial. We hope you now feel confident in integrating scriptable objects into your Unity projects and are ready to build more organized and scalable games. Happy coding!